Hello, I am Rob Prue, Agriculture Technology Systems Specialist with NDSU Extension, and I am here to talk about the concerns with elevated delta T and how it impacts pesticide applications. NDSU has a delta T management scale available that suggests mitigation approaches for different levels of delta T. This is available through the North Dakota Weed Guide, or you can search online to find it as well. And for the purposes of this talk, I'm going to focus on what happens with an elevated delta T. So what happens when delta T values are greater than the preferred range, which represents a high evaporation environment. To really understand the impact of delta T, you need to understand the entire dose transfer of pesticides. So that liquid in the spray tank has to first be atomized into droplets. Those droplets then have to transport to the target. Once they impact the target, they then have to be retained and form a deposit on the target, and then they have to remain in a deposit for long enough to transfer into the target and have a biological effect. So all of these steps have to happen for a pesticide application to be successful. And delta T can impact a few different places in this cycle. One is right away at the beginning when those droplets are atomized, and delta T can impact drift right in the beginning of the process. So a high delta T, again, represents a high evaporation environment. And what this will do to atomized droplets on their way to impacting the target is make them smaller. And smaller droplets are more prone to drift. So higher levels of delta T can increase drift, and that is a concern. And much of that drift is going to be lost. It's possible that some small amount of it will redistribute and still impact the target, but for the most part, those drifted droplets are going to be losses. So drift is one of the main concerns with delta T, but it's not the only concern. The other concern is later in the process, high levels of delta T can also lead to reduced efficacy, so reduced effectiveness of your application. So between when a deposit forms on a target, let's say a leaf, and has a biological effect, there are multiple factors that can influence that deposit. And delta T is one of the micrometeorological conditions that can affect that deposit. And if you have a high delta T, you may have higher volatilization. And I don't mean the active ingredient, you may have a higher volatilization of the dilutant of the water. So high delta T, high evaporation, the water can evaporate out of that deposit on the leaf surface and then strand the active ingredient on the surface of the leaf. If it's an oil-based product, it's maybe not that much of a concern because it could still soak into the cuticle. If it's a solution, you would instead end up with dry active ingredient crystals on the leaf surface, which then can no longer be biologically active. So one example of a product where this could be a concern is glufosinate or Liberty, where those crystals could be stranded on the leaf surface and then no longer have biological activity. Also important to consider is at what time of the day are these conditions going to be a concern? So to get at this question, I analyzed some data from NDON from 2020 through 2022 across 4 locations in western North Dakota and 4 in the eastern part of the state. Focused entirely on June and July, since these are the primary months for post-emergence pesticide applications, and looking at different levels of delta T, with optimal delta T in dark green, lower than that, the marginal low in light green, and then above the optimum in different shades of pink. And again, for the purposes of this talk, I'm interested primarily in elevated delta T. So when is delta T higher than optimum? So the layout of this graph, this is assuming that winds are gusting 0 to 15 miles per hour, so it's conditions that should otherwise be suitable for spraying. The delta T is color-coded as explained on the last slide. From left to right, we're looking at the 8 different locations in both June and July. The vertical component of the figure, we have time of day from morning to evening, and we also have 3 different years, 2020 on top, 2021 in the middle, 2022 on the bottom. And if we look at time of day, what we find is that from about 10:30 onward is when we see these elevated delta T conditions. Very rare is it that we ever saw in this 3-year period these elevated delta Ts any earlier in the day than 10:30 a.m. So if you're an applicator, keep an eye out for this, especially paying attention as you get to 10:30 a.m. and later, looking for these elevated delta T's. What can you do in response? Your main activities to counteract this high evaporation conditions are to use bigger droplets and higher water volumes. So from a delta T of about 14 to 22, these are the actions you can take. But understand that if your delta T is between 18 and 22, it's recommended that you do not use any fine or medium spray qualities, that you would only use a coarse or larger droplet size or spray quality. So if you're using a product that would require fine or medium spray qualities, you really should strongly consider postponing the application of that product until conditions improve. Otherwise, up your droplet size and up your water volume to be able to maintain coverage while using those larger droplets. If you get to delta T values of 22 or above, then it's recommended that you suspend operations until conditions improve. Fortunately, over this 3-year time period, the amount of time with delta T's of 22 and above was actually quite limited. So generally, these unsuitable conditions are not all that common, at least in this 3-year time period. Thank you so much for your attention. To find me online, you can find me on Linktree.